So this is Lab 2, Motion of a Falling Object by Paige Mayfield. So to introduce the experiment, we will be analyzing a wiffle ball's motion falling from a resting position. We will be analyzing 3 different positions in meters versus time in seconds graphs using Tracker, a computational model with just gravity, and then a computational model with gravity and drag force. The goal of this experiment is to observe the motion of an object dropped from rest and evaluate the effect of gravity and drag force on the falling object. So the fundamental physics principles we will be using are Newton's second law, which is F is equal to m times a, and velocity position update formulas. And then we will be using the forces due to gravity and the drag force. So the experimental setup, we have the mass of the wiffle or pickleball included here in kilograms, including the length, and the axis was tilted for distortion, and the video was calibrated for the height and the known length with a negative slope. So here on the right, you can see the movements that were calculated using Tracker to track, and they are here on the right. And then here we have our position versus time graph. Here is the computational model with gravity only, where the initial position, initial velocity, and no drag is included with the last time of observation, the weight force, and the update equations are present. Here we have the predicted motion of the ball, and the velocity is decreasing at a fairly constant rate. Due to the acceleration from the gravity being constant, the slope is not flattening over time, as we can see. And then here is the computational model with gravity and drag, where drag is now included, and the drag force formula is included. And the arrow scale changes for model purposes. Here, we can see the conclusion of this. What does this mean? So the terminal velocity happens when the force of drag pointing up is exactly balanced with the force of gravity pointing down. None of the 3 models reached a terminal velocity. The velocity does not appear to be constant, meaning that the net force does not equal 0. If the terminal velocity was reached, the force of gravity and the force of drag would sum to be 0, indicating a terminal velocity constant equal to 0. What if? What if the ball was thrown? The initial velocities and time when the line on the graph begins to flatten would be different. The slope at the beginning of the graph would also be different. The slope at the end of the time interval would be the same. Here is the link to the code used in GlowScript. Thank you.